Okay, welcome to the second part of the modulus function. What we've got here is just about 3 questions which I think will challenge you, so that's why I've got examples of how to do them. Listen, this one could be any one of the first couple of exercise questions here, but what you need to realise is I've just put a negative out the front, so I've just made it a little trickier. Now the rule for these is the same as I said in the notes. The first thing is sketch this guy, okay? He's not difficult at all. Secondly, is you go, alright, let's put the modulus around it and reflect all the negative y values in the x-axis. And the last thing to do is simply reflect everything in x-axis. Okay? Because in your transformations, like if this is the original function here, if I stick a negative out the front, you would tell me that that's a reflection in the x-axis. Okay, so the transformations can now help us. Okay, so let's get started. So we're going to start with this guy. That's not too bad at all to sketch. Okay, so it's just a truncus and it's been translated by 2 units down. So you got asymptotic behaviour at y equals -2 and asymptotic behaviour at x equal to 0. Okay, and we've got that truncus sort of behaviour. Okay, so I'm just going to draw that in. Okay, a bit dodgy here. Just pretend you didn't see that. Okay, now it is important to find these x-intercepts because they're going to be key points to move around because we're going to have to move this graph around. So if we just let this graph equal 0, that's x-intercepts. We'll just do that really quickly. Alright, and just rearranging it, you'll get x squared is equal to 1/2. I'm just running out of space, I'll just squeeze it down here. Okay, and take the square root of both sides, we'll get x is equal to plus or minus 1 on root 2. Okay, really fast, but I think you can just go through the working of the algebra yourself and check it. So the 2 values here are 1 on root 2 and minus 1 on root 2. So that's step 1. Okay, we've done that guy. Now, this is where this graph looks amazing. Okay, what we're going to actually do is put the modulus around it, and it's going to make it look fascinating. So what we're going to do is just do another sketch and just use this one. So what we've got to realise is we've still got this stuff happening. Okay, because all those y values are positive, so they don't get touched, okay? However, and I'll just dot them in, all these guys underneath, okay? For example, this y value here was negative, it's now going to be reflected. Reflected, reflected, etc. So then you get this beautiful looking graph, look at that. Alright, and it's a bit freehand, but you're going to get this asymptotic behaviour. Now the asymptotic behaviour was at y equals -2, excuse me, but now it's at y equals +2. Now this is the bit that gets kids, okay? Basically you're going to say, well hang on, the graph is crossing the asymptote. You need to be careful here. You need to realise that this asymptote here really was in play for only this part of the graph, okay? So now that we've reflected that part of the graph, the asymptote really only exists for that bit. And similarly for this side, the asymptotic behaviour only existed here. And now that it's been reflected, the asymptotic behaviour is there. It comes back to the hybrid concept, okay? This bit here is really a different graph, okay? Now, we're almost finished. The last part, and I must admit I almost ran out of space, is we have to reflect it in the x-axis. So, it's getting a bit crazy, but what we're actually going to do is just try and do it in the same graph. So simply everything gets reflected. So this is actually going down. So it's going to look like this. It looks fantastic, doesn't it? And then this graph actually gets reflected as well. So you end up kind of with a original version sort of mutated, crossed around, goodness knows what else, but that's what we've got there. So the actual final graph is this guy, okay, there and there. And so you still have that asymptotic behaviour at x equals -2. Alright, that's one of the harder ones, but remember the basics of these, and this is like for question 1 and 2. Sketch what's inside. When you put the modulus, reflect all the negative y values in the x-axis, okay, and then whatever else you have to do. Alright, let's have a look at the next one. Okay, the next one is actually sketching a hybrid, okay. So here's the hybrid. There are other ways to sketch it. If I get time I might show them. But the rule is, okay, so we'll just write our hybrid out. When the thing inside is positive, okay, you just leave it alone, okay, so it's just 2x take 2. However, when the thing inside is negative, a quick way to change that negative value is to simply multiply it by -1. Okay, so you just put a negative out the front. So let's tidy that up. So just quickly tidying it up, we've got 2x, take 2 at the back, top hasn't been changed. Put the 2 on the other side, and then divide by 2, you'll just get x is greater than 1. I know it's quick, but can you just see that? Put the 2 on the other side, so it's 2x is greater than 2, and then divide by 2, you get x is greater than 1. Same inequality here, okay, it's just less than 1 though. Okay, be careful, this is different. Okay, look, multiply that by -1, you get -2x. Multiply that by negative, you get +2. Okay, so that's the actual graph. Now we have to sketch it. Alright, so what we might actually do is sketch it over this side. And we'll do a nice big picture for it. So really this is the graph 2x take 2 when x is greater than 1. So we'll just pick 1 out there, sub in that value, and that's kind of like its starting point. Remember, you can kind of put equal there, you'll see that in the book. So sub in 1, you'll get 2 times 1 is 2, 2 take 2 is 0. Okay, so that's the starting point. It's a linear equation, so that's the y-intercept. So we'll just go down to -2, and you can kind of just, even though it doesn't exist for that, just sort of carry that line on. Alright, now this graph, sub in 1, because that's its endpoint actually, because this is the domain for the first one, and this is the domain for the second. So let's just sub in the endpoint. So you got -2 plus 2, surprise surprise, it should finish in the same point which starts the next graph. Now the y-intercept is +2. Okay, so there it is. How many points do you need to draw a straight line? 2. Alright, and that's done. There are other ways to sketch it. I mean, you could try a few other things like doing that. Making it skinnier, that's a dilation of half. It's actually making it a bit wider. Dilation of a half from the y-axis and 1 to right. But you can actually see there's the 1 to the right here. Okay, so the hybrid is a really tough thing to do, and it does take a lot to get around, and I'm going to show you a one that's a little harder, okay, for the final one. So the last question I'm going to give you is going to be crazy hybrid or easy way. Okay, so we're going to do the easy way first, and then I'll show you how to write it as a hybrid, and we might just leave it there. So this thing here can be broken up into certain steps, just like we did before. You've got a +4 at the back. So the first step, what you can actually do, you just break it down. You start with this guy. That's a parabola, not bad at all. Okay. Second step is, like I've always been talking about, going, hey, when you put the modulus around it, you should know it by now. You're going to reflect all your negative y values in the x-axis. And the last thing, you can see, to whatever that function is, you're adding 4, which is simply going up 4. Okay, so that's a translation of 4 units up. So let's have a go at it. So I'm just going to grab this guy and just quickly factorize it. You've got x take 2 and x. So if you let that equal 0, you know that x could either be equal to 2 or 0. Okay, so let's just quickly sketch that guy over here. Alright, so 0 or 2. So I'm just going to do that in a dotted line. This graph is going to change 3 times. You saw it happen with another one. Well, forget about that, but it is a parabola. Just use my imagination, but it's going to change a lot. Now the next key is to do that. Now before we do anything, this point is a key, this point is a key, this point is key. These are easy, 0 and 2, but we need the turning point. Now you could just quickly diff it. Let's just diff it just down the bottom here. So dy by dx would be 2x minus 2. And if you let that equal 0, I don't know if you can just see by inspection, it's when x equals 1. I mean, you don't even need to diff it really. Look, halfway between 0 and 2 is 1 anyway. You sub in 1 into the equation, you get 1 squared take 2, which is minus 1. Okay, key point. Now, modulus, reflect all those negative y value answers. So the original graph would let you get a y value of -1 here, but because it's got the modulus, it's going to push it up to -1, and etc for all those other values. Okay, so that's what the graph is like now. We'll rub off that bit. So really you've got this W happening. Okay, looks great, doesn't it? Alright, so the positive bits stay positive. That's negative, but now it's become positive, and that was positive in the first place, so you leave it. Last thing to do is just go up by 4. Okay, so you track these points, this point, and this point. Okay, they're key points to move. So if you move this one up by 4, you'll get to 1, 5. You track this one up by 4, you'll get to 2, 4. and you track this one up by 4, you get to 0, 4. And so your final graph, a bit messy, but I just want to do it all on the same page. Looks like that, okay? Yeah, a bit dodgy, but you know what I mean there. Okay, we're running out of time. This is a long one. Let's just quickly write this as a hybrid. Okay, so again, this is the thing inside. So you can write it as a hybrid in the sense of saying, when the thing inside is positive, you just leave it alone. Okay, when the thing inside, sorry, that's positive there. When the thing inside is negative, you put a negative sign out the front. Now this thing I'm not worried about, okay? It's this thing, okay? And this is one of those inequality things that we should have struggled with earlier in the year. So we'll just tidy it up. We'll do the easy part. This is really x squared minus 2x plus 4, but this is minus x squared plus 2x plus 4, okay? How do you deal with them? Now, we've just sketched the original over here, if you can see it. Okay, the x squared minus 2x, there it is there. Now remember what I said, just graph y equals x squared, take 2x, and then you know that this is y, so what you're doing is looking for when y is greater than 0. Now if you can see here, all the y values are greater than 0 there. We know that that was when x was 2. And we know all the y values are greater than 0 here, and that's when x is less than 0. Okay, so just when x is less than 0, when x is greater than 2. So we can actually rewrite this in this inequality as x less than 0 in union with x greater than 2. And the last part here is, when is that less than 0? Well, it's just this area in here. So when x is less than 2 and when x is greater than 0. Alright, that's it. That one was a bit longer. Okay, so this one's about 12 minutes, but I hope they help a lot. Okay, good luck with exercise 2F, and hopefully you get through most of it. Okay, see ya.